back to 3.2, and we want to talk about what is the relationship with graphs and how it equates to or how it relates to just solving equations. That's really what we're getting at here. Now, I'll say this, we're going to have this quick conversation. This is not anything that you'll be tested on, okay? It's not something that shows up in the homeworks, but gives a really good idea to just all the connections that we've done and how there's a relationship to equations and solving. So let's just get the graphs plotted first, and then we'll have this conversation. So if you notice, everything that we're trying to graph, there's going to be two equations, and for each set of things we're trying to graph, y equals 4 shows up on both of those. So let's graph all the y equals 4 for all four graphs real fast, which is a horizontal line where y is equal to 4. Okay, so we've already got one of the two things we need to graph for each set here. Then, just a quick graphing review. And actually, when we're graphing more than one equation on the same axes, that is called a system. We're going to have a whole unit about systems when we come back second semester. So we'll actually get more graphing review second semester. We'll also talk about how we can solve systems without graphs as well. So when we have a system and we graph multiple things on one set of axes, we're looking for where they intersect. So when we make our graphs here, we want to make sure we use the slope enough times to where we see the point of intersection with the line that we just plot. So x minus 4, that is linear. I do not see any parentheses telling me that the x-coordinate is 0 and the y-coordinate is negative 4. So that's a y-intercept at negative 4. Then we're going to use the slope of 1 in front of the x as an invisible 1. So I'm going to go up 1 and right 1, and we're going to do it enough times until we find where these intersect. And then we're going to circle that point of intersection. And again, we'll come back to this in a second and talk about what that means and its relationship to solving. So next graph, part B. Absolute value of x minus 4, same idea. There's no number inside the brackets telling me that x is 0, and thus the y is negative 4. The a value or the slope is 1, telling me to go up 1 and over 1 in both directions. And again, we get to do this a bunch of times until we get to where it intersects. I'm going to do it on both sides here. And then this time we get 2 points of intersection. Okay. Next graph is a quadratic, x squared minus 5. No parentheses, tell me that x is 0, and thus that negative 5 is the starting y. Then using the a value, which is 1, I'm going to first just go up 1 and over 1 in both directions. Then we go up by 3 times that a value, so I'm going to go up 3 and over 1 from there. And then that's really all we did when we graphed quadratics, right? We did vertex, a value, 3 times the a value. If we were to continue with that pattern, the next one would be 5 times the a value. So from there, I'm going to go up by 5 times 1 or up 5. And that's what brings us to the line that we're looking for where it intersects. Once again, there's 2 points of intersection. All right, and then the last graph here, the exponential, instead of making our table and going through plugging in -2 and +2 and all that, I'll just plot our points here to make it go a little bit faster. So we do have that horizontal asymptote at -4. And then as we start plugging in x values, if we plug in 0, we're going to get -3. That's the y-intercept. If I plug in 1, I'm going to get -2. If I plug in 2, I get 0. If I plug in 3, I get 4. And that gets us to our point of intersection. Okay. So what we're doing with the graphs here is we're illustrating that there's always a relationship to when you're solving an equation. There's a graph that represents the equation that you're solving. So in part A, when I have x minus 4 and y equals 4, really what we're doing is we're representing the solutions to the equation of x minus 4 equals 4. Okay, so we have the line. We set it equal to the 4 on the other side. And then if we were to solve that, I would add 4 to both sides, and I get x equals 8. Well, if you look at where these lines intersect, what's the x-coordinate for where those two lines intersect? Oh, come on now. What's the x-coordinate there? It's 8. Okay, so when we graph lines, or if we have an equation, we can graph one side of the equation, graph the other side of the equation, and where they intersect. Okay, that x-coordinate is our solution. So we would say the solution here, x equals 8. All right, now that same idea continues for all these other graphs. Okay, absolute value of x minus 4 equals 4. So if I just take the equations, set them equal to each other, that is represented on this graph below. If I were to solve that, I'd add 4 to both sides. Absolute value of x equals 8. Well, what numbers can I take the absolute value of that get us 8? Plus and minus 8. And if you look, that is exactly the x-coordinates we get for where these lines intersect. So our solutions here, x equals 8 and x equals negative 8. So the same idea continues for all our other functions. Okay, with part C, when we have this quadratic, we're checking to see where does x squared minus 5 equal 4 at, okay, represented by the graph below. So I would add 5. So x squared equals 9. Then square rooting the 9, I get x equals plus or minus 3. Well, if we look, that's the x-coordinate for where those lines intersect as well. Okay, so the two solutions there, x equals negative 3 and x equals positive 3. Okay, it kind of gives us another representation for why we're getting two solutions for the absolute value and the quadratic. All right, and then the last part here, for the exponential, 2 to the power of x minus 4 equals 4. I'd add 4 to both sides, so 2 to the power of x equals 8. Then we'd list all the exponent facts, so 2 to what power gets us to 8? That would be 3. 2 to the power of 3 is 8. And once again, that is where our lines intersect at the x value being 3. Okay, so again, the whole point of this conversation is just to, again, make the connections between graphs and equations, and every time you're solving an equation, there's a graph represented by that. We're going to have a whole unit of this second semester where we also include the y-coordinate, but just want to throw out that, yeah, when we're solving, graphs can be a way to help us find solutions and can help us decide how many solutions we should get, depending on how many times they intersect. Okay, that is it for this section of the